Hello, everyone. My name is Han Wang. I'm a research associate at Urban System Lab from Imperial College, working with Dr. Aruna Sivakumar and Dr. Jacek Polak. We are excited to have the opportunity to present our ongoing research here at Energy Futures Lab Research Seminar. And the topic is UK consumers' willingness to pay for low carbon heating key factors. So this research is part of two UK projects, the adult integrated development of low carbon energy system and EDRC Energy Research Demand Research Center. And my presentation will cover the following points. I will begin with this research's background, rationale, objectives, followed by the data collection method. We have conducted 2 waves of domestic heating surveys, including the reviewed preference survey and the stated preference survey. And then the focus is on the 3 sets of choice scenarios in the SP survey. And also the mixed logic models we built around them. These 3 sets of choice scenarios focus on different aspects in the transition to low carbon heating. The first one, XP1, focuses on technology, XP2 focuses on retrofit, and XP3 focuses on ownership and services. And last, I will conclude with the findings and outline the next step for this research. The background, decarbonizing the energy sector requires multiple strategies to achieve the 2050 net zero emission targets set by several nations around the world. In Europe, the heating and cooling sector account for half of the final total energy consumption. And a large portion of it relies on the combustion of high carbon fuels, which have a substantial environmental impact. So therefore, the adoption of low carbon heating technology has become critically important. The electric heat pumps, as a key technology in low carbon heating, have witnessed remarkable market growth in the real world. For example, in 2022, Italy sold nearly 500,000 units, and the sales in Czech Republic and Belgium doubled. And the Poland have seen an increase more than 120%. But in contrast, in the UK, the adoption of a heat pump only increased 40%. It's been quite slower. Another notable alternative is to substitute the natural gas in boiler with hydrogen, which is quite environmental friendly because there's no carbon emission. And but the acquisition of these low carbon heating alternatives is associated with substantial expenditures and potential retrofit costs and disruptions. It also involves the trust in this technology, the perception of its reliability, the expected financial support, the opinions on climate change and decarbonization. Therefore, understanding consumers' preferences is important not only to drive the decarbonization agenda, but also to support the emergence of products and services that can achieve the desired policy objectives in an equitable fashion. So the objective of this research are threefold. First one is to get a better understanding of consumer perspectives in the transition to low carbon heating. The second is to explore the role of technology attributors and the broader context of retrofit and overall service provision, especially with novel services such as the shared heating or the demand-side response. The third objective is to assess the relative importance of economic and financial attributors compared to other factors like the nuisance, disruption, control, and flexibility, as well as the attributors and lifestyle. So we can calculate some exact values, or we call willingness to accept or willingness to pay for these factors. So to collect the data, we conduct 2 waves of online survey in the UK in 2023 and 2024. Wave 1 is to understand the existing heating system or status quo. It is a state reviewed preference survey with more than 1,000 participants. And the second wave, wave 2, is aims to understand the willingness to adopt low carbon heating. This wave, second wave, is a stated preference survey with more than 500 participants from the wave 1. Now I want to give more explanation about the difference between reviewed preference survey and stated preference survey. Wave 1 reviewed preference survey based on the idea that people's actual choice in the real world reflects their true preferences. So the reviewed preference RP survey analyzes the real world decision based on the observed behaviors or the existing situation. On the other hand, the second wave stated preference SP survey focus on the hypothetical situation, where participants are asked what they would do in a certain situation. So this SP methodology survey is quite important when the real world behavior data is unavailable, or when the choice scenarios only happens in the future or haven't happened yet. And so you can tell the difference between these two kinds of survey based on the types of questions in them. So in wave 1 reviewed preference, we ask questions about participants' current property characteristics, their household member, their lifestyle, their existing heating system, and heating cost. We also ask about their attitudes and awareness to general idea about climate change, energy conservation, and heating technology. While in the second way, stated preference survey, we designed 3 sets of choice scenarios to ask what they will choose under these hypothetical situations. We also ask questions about their attitude toward demand-side response, which I will explain later, and their environmental portrait value, and also their agreement with some comments. So in these surveys, we designed some quotas to ensure the full coverage of different kind of participants or consumers, such as the owners, the landlords, the renters of property, and also property with or without the gas boiler, or whether the gas boiler has recently been replaced. Similarly, in the SP survey, the attribute levels are specifically designed for different segments based on some factors like the property type, whether it's a flat or house, well, based on the construction year, whether the property is built before or after 1965, and the property size, was a large one or a smaller one. And right now, we are processing the data and preparing for the data sharing. And we welcome the collaboration for further analysis when it's ready. In the meantime, right now, I will present some interesting questions and topics from this survey to get your attention here. First, in the wave 1, we have questions about their already existing improvement and renovation work, such as the window glazing, the insulation, and the temperature of their hot water, the reasons for recent replacement of the heating system. For example, their choice like I replace it because I moved to a new property, I replace it because it's failed, or I replace it because I want to have a more eco-friendly lifestyle. And then we ask about participants' gas and electricity supplier, their tariff, their occupancy and activity schedule. And we also have questions about their attitudes about replacing the current heating system and financing, how to financing this retrofitting, and their attitude toward climate change, eco-friendly lifestyle, decarbonization, and the trust in different sources of information. And we also ask what's their preferred ways of monitoring the savings. And then in the second wave SP survey, we have questions about whether they agree with some statement related to demand-side response and their feelings, such as what's their accepted minimal notice period for the change, what's their accepted event number and emotions. And we also have some questions to evaluate their environmental portrait value, such as to assess to what extent they are altruistic, biospheric, egoistic, and hedonic. And then we estimate mixed logic models incorporating contextual and statement variables, and the utility of a person for one alternative in a choice scenario is in the center. And there are basically three main types of variables. First is attributors in alternative, such as the cost of some technology, the contract length of some services. And second type is contextual variables, such as participants' social demographics, their age, their education level, their income, and the property characteristics, what's the type of their property, and when the property was installed. And the third type is statement variables. Basically, it's about their agreement, their attitude. For example, how similar you think yourself to a person that you know it's important for him or her to prevent the environmental pollution. And then let's focus on the second wave, the wave 2, the stated preference survey. And here we designed 3 sets of choice scenarios to ask a participant to choose from 3 alternatives. And for each alternative, they are characterized by some attributors, and these attributors have multiple levels. So these value levels will vary across different choice scenarios to encourage participants to consider not only the alternatives itself, but also the attribute levels. So we can understand how they trade off between these attributors and technologies. But you may notice when the number of these attributors and the number of these value levels increase, the required scenarios to cover all the combination of them increase exponentially. So it is impractical to present all the valid scenarios to the participants. So we use, to address this problem, we use a technology or approach called efficient design. So efficient design will reduce the number of required choice scenarios, but still capturing the critical information in the models. It aims to reduce the variance of estimated parameters in the model and allow us to get a more accurate estimation of these attributors. So for SP1, the first set of choice scenario, we focus on the technology. Participants can choose between gas boiler, hydrogen-ready boiler, and a heat pump. And before all these questions, we will give them very detailed description of how this technology works, how this equipment works, and explain all the attributors to make sure the participants understand the situation and all these things. And so this alternative will be categorized by attributors like fixed cost, annual cost, and equivalent monthly cost of operation. The financial support scheme, we have 3 levels here: the no financial support, or the interest-free loan, or a 4% loan. And we also have maintenance visit, means the inspection and maintenance per year, whether it's once per year or twice per year. And then the carbon dioxide emission, we give them the exact value for the emission, but also we give them the equivalent value of a single person economic flight from London to Glasgow to make sure to give them a more direct impression of how large the emission is. And then the result is shown on the right. So these are the coefficient of these attributors. You can compare, you can find whether they are significant or not. So based on the result, we find the sensitivity to monthly cost is much higher than the upfront, the fixed cost, which makes sense because people usually look at the cost at the long term or the life cycle cost expenditure here. And we also find the financial support scheme is influence the choices. Even with the non-zero interest rate, they can very promote the adoption of low carbon heating technology. We can even calculate their equivalent monthly values for this financial support. So these values can help the policymakers or some insurance companies design their products here. And then the maintenance visit does not affect the choice here mainly because they are very infrequent, like only once per year or twice per year. And surprisingly, their attention to carbon dioxide emission is only marginally important. So it doesn't have significant impact here. And there are some significant contextual and statement variables. For example, the likelihood of choosing hydrogen boiler or heat pumps increase with higher level of biospheric values and eco-friendly lifestyle, the lower awareness of the disruption, the absence of an existing gas boiler, the fewer rooms in the property, the more senior adults, and the higher annual income. Some of these findings are interesting, such as, for example, the lower awareness of the disruption actually reduce the likelihood of choosing low carbon. Lower awareness actually reduce the likelihood of choosing this thing, because usually we may assume a better understanding of the disruption will reduce the concern of new technology, but actually here the result shows if we know more about the disruption, it may actually discourage us from adopting it, because when you think about idea, we think it's good, it's eco-friendly, we will choose it. But when we consider deeply to think how to do that, okay, there will be a lot of disruption. Okay, then forget about it. And then the absence of an existing gas boiler will increase the likelihood of choosing this new technology. It shows the inertia of the existing one, but also shows the preferences for the gas boiler. And the second set of choice scenarios focus on the retrofit. Again, there are three alternatives. First is no retrofit, means the consumer is only replacing the heating system. The second alternative is minor retrofit, means involves something like the trough insulation or the hot water tank insulation, in addition to replacing the heating system. And the third alternative is a major retrofit, such as the floor insulation, the wall insulation are very intensive retrofitting. And here we assume there's no specific technology involved, so that the participants will focus on the retrofit. And then there are several attributes here. The equipment cost of this retrofit, the retrofit cost, the nuisance duration, how long does it take to do all this retrofit, and the savings on the monthly saving, and the payback year. We also have the financial support scheme. And in this set of choice scenario, we observe a large amount of non-trading or serial answers, which means participants always choose one alternative, regardless of the change of attributors. So it indicates the preferences for the no retrofit and the minor retrofit. And these no trading answers are removed at this stage to make sure we get a more accurate analysis. And based on the finding, we find the retrofit cost and the payback year influence the choices, although most of these effects are marginally significant. And then similarly, there are significant contextual and statement variables. For example, the individuals with biospheric values prefer minor retrofit over major retrofit. And major retrofits are less favored if the current heating system have been in place for 1 or 3 months, which I think makes sense, because if a heating system have already running for more than 1 year, there's less likely it have a significant issue that require major retrofit. And then the larger properties pose barriers to minor retrofit because usually it will involve more retrofit costs and more disruption. And then properties are less likely to pursue further retrofit if they have already invested in one. I guess this probably because repeated retrofitting can cause more money, more disruption, and frustrating. And then the presence of teenagers increase the preferences for minor retrofit. I guess that's because parents want to provide thermal comfort environment for their children. And the higher education level increase the likelihood for major retrofit. Third choice scenarios is for ownership and services. Although similarly, they have three alternatives. First is full ownership, means consumers fully buy and own the heating equipment. The second alternative is shared ownership, involves a larger heating system shared within a neighborhood or community. And the third alternative is service-based, means consumers don't buy and own the heating equipment, but they rent the equipment from a service provider, and they are signing some contract for the service. And the tributaries here include the upfront cost, the annual cost and equivalent monthly cost for operation, the contract length for some services, the energy pricing and control and service flexibility. Now I want to emphasize the last two attributors because it involves the demand side response. The demand side response is using incentives or price signals to adopt consumers' electricity consumption to meet some grid requirement. For example, to reduce the peak demand or increase the electricity consumption at the off-peak hours. So this demand side response is important for the grid to reduce the peak demand and also help fight against climate change and energy crisis. And these two attributors here both have three levels. The first level of energy pricing is a constant price. They don't change across hours or day. The second level and the third level of energy pricing is the price can change at some hour during some periods, but with a notice 1 hour or 24 hours ahead, they have a notification for the change. And the first level of control and the service flexibility means the heating system is fully controlled by the consumers. And the second and third level of control and service flexibility means their heating system can be turned off. So we call it switch off event, turned off by the grid or the central controller for 1 hour per month. And with a notification 1 hour or 7 hours in advance. Of course, they will get some compensation like £14 here. So these attributors will help us understand consumers' preferences for demand-side response experiment or strategy. And also in this scenario, we observed the non-trading answers that prefer the traditional full ownership because people don't want to lose control. And based on the result, we find again sensitivity to the monthly cost is higher than the upfront cost, and we can calculate the willingness to accept value for the demand side response. The dynamic price and the switch off event, it basically means how much money participants will get when they accept this price or when they accept this switch off event. So we got the exact value, but we can observe the confidence interval for this value is quite high. Even the high confidence interval, we can observe the increase in willingness to accept value from full ownership to shared ownership and service-based ownership, means consumers have different preferences for demand-side response in different ownership. And there are some significant contextual and statement variables. The biospheric and the egoistic values influence the choice. We also observe the nonlinear impact of money already spent on the improvement. And interestingly, if there are more employed people or more adults or more senior adults, they decrease the preference for the shared ownership or the service-based ownership. because I guess adults don't want to lose the control over heating. And higher education levels increase the preferences for service-based ownership, because I guess because they are more receptive for the new services, new technology. And back to the willingness to accept for demand-side response, they are among the most significant and interesting findings of our research, because once we got this value, we can use them to support the policy making. What kind of reward should be given to participants if we want to promote this experiment? But you can see the willingness to accept value here is quite large, especially when you consider the switch-off event already include a 14 pounds compensation. So these values are high. And another instance in the UK is National Grid have conduct a demand-side response experiment called Demand Flexibility Service, DFS, where consumers can participate in events that reward them based on the reduced electricity consumption in certain period. However, more than 60% of participating households get a reward less than 10 pounds. So you can see the significant gap between the willingness to accept value in our result and the reward in the real experiment. But we do have some reason to expand this gap. First, in our hypothetical situation, the demand-side response is direct control over heating. So, but in the DFS, the real-world experiment, participants can choose or reject each single demand-side response event, and they can choose to turn off non-heating appliances. So it is not surprised that people have higher willingness to accept value in our result. Second, the real-world DFS is an experiment for a short time, and participants can get many non-financial reward, because from the report, some households say they are happy to join this demand-side response because they see it as a challenge and it unites their households. It's a good chance to educate their children. And the third reason is there are prevalent complaints about the low reward in DFS, so they may consider to increase this reward. And finally, our research provides valuable insights on how people trade off between different attributors. First, the gas boiler is still preferred, but if we can provide more affordable pricing and financing options alongside increase the environmental awareness, they can make some difference here. And second, the no retrofit and minor retrofit are still preferred, but the payback year play a significant role in deciding the scale of the retrofit. From the flexibility perspective, the traditional ownership is still preferred over the service-based and shared ownership. And we obtain the value for the willingness to accept of demand-side response, such as the dynamic pricing and switch-off event. For the next step, we have observed the linear impact of attitude and statement, but we are trying to integrate the latent variable to more accurately capture their non-linear impact. Some potential latent variable include their environmental value portrait, such as to what extent the consumers are altruistic, biospheric, egoistic, or hedonic, and also the participants' satisfaction with current heating system, or their confidence in switching heating system, and their eco-friendly lifestyle. And last, we welcome collaboration to further analysis this data set. And if you are interested, please reach out to us. Thank you. And I'm happy to answer any questions here. Yeah. Yeah. Please. Yeah. Yeah. Yeah.
If you could just walk me through what those numbers mean. So this is saying to someone, if your heating went off for what, an hour?
Yeah, from us.
What price compensation would you be willing to accept
Yeah,
for that to happen? Right. Okay. Okay. And is that then so obviously we're focusing on heating, but is that then that you would lose power, that the power would go off for everything to your whole property? Or
for this scenario, we only consider switch off the heating. So there are other electricity still on, but the demand side response is originally from the electricity system. So there are a lot of switch off event, and also the DFS is mainly involved the electricity rather than the heating. But here we want to focus on if we use the same idea in heating system, what's their preferences and what needs to set.
I suppose you could get over that. Could you get over that by saying you just don't draw from the grid for your electric heating? So if you had a battery, you wouldn't be switching their electric heating off. You're just sending a signal somehow to say, rather than running your heat pump during this 1 hour period from the grid, you switch it with a home energy management system. I guess that would be a solution. If you've got an in-home battery,
yeah,
flexibility.
a heat battery.
Yeah, well, no. Well, yes, a heat battery, but you actually have a normal lithium-ion battery in the home.
Yeah.
So normally during this, you've got your 1 hour period at peak. You're running your heat pump through the grid, but
yeah,
you just don't draw from the grid. In fact, you switch over to your home battery, and so the resident doesn't experience any change. It just comes from a different source.
yes, that's also accepted in the demand side response, because the final objective is to reduce the peak demand or the peak electricity consumption. So when you switch from the grid to the battery, you also reduce that. Yes, that's one solution to demand side response.
And just, I know early on in the thing, you said it was when you had your boiler, your hydrogen and your heat pump. And I think you said that if you did every kind of nuance, you would have so many different situations to describe. Yeah. Did you make any distinction when you said air source heat pumps, whether it was air to water or air to air?
Sorry, what do you mean?
You got your heat pump, so was it just a generic, what do you think of a heat pump?
Yeah.
As opposed to a heat pump running the radiators or the heat pump heating the air?
You mean different kinds
of heat pumps? Yeah, you didn't make that distinction because you didn't want to over.
Yeah, because that will have too many alternatives. Yeah.
From Anthony asking, are you only assuming carbon emissions at endpoint rather than full life cycle? Zero carbon assumes zero.
Okay, so very, very good question. So here, actually, the carbon emission we only consider at one point. We didn't specify where this emission come from. Maybe I think it covers the whole lifestyle, but it can, as I said, it have several levels. It can be zero for hydrogen and air source heat pump, but it also can above zero for this thing. It depends on the assumption whether this heat pump, whether the electricity to support the heat pump or the are from renewable energy. If the electricity for heat pump is from renewable energy, the carbon emission will be zero. But if it's from the fossil fuels, obviously there will be carbon emission. Yeah. So in different scenarios, this will all change to make sure we cover all the situations. Yeah.
One other question from Elisa saying, did you see any significant changes in preferences in 2023 versus 2024?
I said this because these are two waves of survey. We do the first wave in 2023 and the second wave in 2024. So we didn't observe we cannot compare the difference for the preferences here.
Last one actually from Neil asked, why is the air source heat pump so cheap?
I was going to ask, I think, the same question to in terms of running cost, maybe. I don't know. I'm surprised that your figures here suggest it's only like 50% running cost. Is that right? Whereas I thought traditionally they were actually quite close in terms of running.
Yeah. So I may give more explanation of how we design these values. So here, as I said, each attributors have many levels. So what you see is here is just one example. So one example of the choice scenario. For the next scenario, this number could be 19,000, or this number can be 25 or 40,000. So all these values will vary across these choice scenarios. And these values are we designed based on literature review, and some colleagues, they are from chemical engineering. They have done some research in the market, in the literature review, to find what's the potential values for all these alternatives. So we select some levels of them, put them in different scenarios. Yeah. So sometimes this can be lower, sometimes they can be high. So
It's more like modeling assumption.
yeah.
Than
Yeah. So
like
because
forecast or
because they are different in different scenario, and based on this change, participants will think in their head of which one they prefer and how the values influence their choice. The values will change here. Yeah.
Be a few more coming, but they're just typing.
And
I suspect that 3,900 might just be to put in an air source heat pump without doing the whole pipe work and radiators. Could almost double it with if you do that. So yeah, again, coming back to your too many scenarios would just overwhelm people. So it's a difficult one to model. So I can see why you've slimmed them down. Earlier on, I think you mentioned there was the pre-1965 age of property and post-1965. What was the significance of that year?
of here,
Construction year.
yeah. So first we do the first wave survey in 2023, and we got all the data about their existing heating system, existing property, when they are built, when they are installed, and then we analyze this data to find the better way to separate them into different segments. So our colleagues do some clustering algorithm to make sure if we divide them based on these factors, we can have more coverage and more direct, more coverage of them. So they are result from some calculation, clustering algorithm.
I was interested to know, actually, for the people without who don't currently have a gas boiler, because you said they're more likely, is that right? That increases the likelihood. What kind of home heating situation would that be typically? What kind of things do people have? Just like plug-in heaters, or? Yeah, we also ask whether what's their current heating system. Someone have gas boiler, someone have a heat pump, someone have even burn the wood or something. But very few people have that, and also portable electric heater, something like that. So a lot of answers here.
I would have thought there'd be quite a few oil or LPG. They're more rural.
Then
there's still more than you think. So they're probably the ones to go for to do the heat pump transition and to get things going. The other thing I was quite interested in, it's more an observation, is that when you know retrofit, your basic and your major retrofit, looking at the measures, I would say perhaps future, that there's somewhere in between minor and major.
Yeah.
Major is that expensive, and what you can do, you can have a whole house survey that creates a long-term plan of what you need to do. So you do this measure, over the course of a number of years. And I can't remember, there was a report out very recently which said if you go down the major retrofit road and said that's what you got to do, you're going to turn so many people off. And the minor retrofit is, you're doing a little bit, but there needs to be somewhere in the middle, which is, and it's a big debate about fabric first, fabric fifth, then where do you put it in? Because if you say you have to do your fabric before you do the heat pump, again, you're limiting your amount of people who want to do it. So you could just put smart heating controls, a little bit of loft insulation, and then the heat pump, that would do a really good job, rather than, it's the phrase, you don't want to let the best be the enemy of the good. So you just do a smaller package, which is above minor, but some medium retrofit. So just a comment for future, perhaps.
Yeah, I agree. This alternative are just some abstract concept here, because for people to understand and to make the choice. But in reality, there are different process to undertaking these things, and a lot of options. Yeah,
I think you're very true about where people are in that life cycle of their heating system. Because if you have had something done in the past 3 years, you're not going to go you almost want to do everything but the heat pump. Do any insulation, your heating controls, and block up any drafts and ventilation. So then you're heat pump ready when your boiler inevitably breaks down in another 6 years to get everything ready. So, but yeah, that doesn't surprise me about the 3-year gap at all, 3-year history.
More online. Someone else, was the sample the same or different across the SPs, and was it the same sample as the RP?
So the sample for RP is more than 1,000 participants, and among them we recruit more than 500 people. So the sample from SP are from this a part of the sample in SP in RP. Sorry.
Another one from Christopher. He asked, based on these findings, what would your top recommendation be for a government policy to increase heat pump adoption?
So the key findings and suggestions for policymakers are provide more financial support here to reduce their financial burdens, and also do some more promotion education to increase their environmental awareness. Yeah.
A final question from Anthony. Did the property ownership types, resident, landlord, renter, impact anything? Because I don't recall seeing it come up in the results.
Yeah. So actually, we have we do include some of this. I remember where it's but it's quite hard to analyze the result because we have several types of property type, like the bungalow, the terrace, the flat, something. But the result is quite sometimes can be confusing because some property type can have a higher likelihood to choose heat pump or hydrogen, but we don't know the reasons behind that. So currently, I didn't show that result here, but definitely that's one direction can do further analysis. Thank you.
I thought it was quite interesting that the ongoing costs are actually more important than the upfront.
Yeah.
And what was it? It was even the non-zero interest rates were effective. So when you talk about more funding and finance, it's not obviously stimulate the market with grants now, which is what they're doing. But over time, that needs to transition to funded options. And it's non-zero interest rates. So, so the commercial providers can come into it. Like,
yeah.
Commercial is 4%. I don't know, but really interesting that people are still willing to pay.
Yeah, and this result also align with existing literature. I remember some reports is 2 key factors influence the transition to low carbon heating is the cost and the expected heating performance. People first, of course, the cost is a key factor, and then people may worried if they switch to heating system, the thermal performance will be lower. They may afraid they don't get the enough heat. So that's why people will sometimes do the retrofitting along with switching to heat pump to make sure it have the same level of performance. Yeah.
I just find it's interesting that people spend £30,000 on a new kitchen and they don't really think about what's the payback, what's my break-even year, and yet something which is probably less than 10,000, they still want to see a payback period and a break-even point for something like that. It's perhaps people have been too used to grants for the loft and cavity insulation in previous years, but yeah, I mean, you do an extension value to the house, but even that's quite abstract. But you don't think of what's my break-even point on a new kitchen. Observation again.
Have you seen the Public First report just recently?
No.
On this topic? I mean, it's not just heat pumps, but it's about home retrofit in general. One of the points they've made is that people might like to show off their new kitchen to their friends. It has a sort of bragging value, whereas the heat pumps don't quite have that yet for people.
That's partly to do with probably their design. They're very functional. They're like the heat pumps and the air conditioning you'd see around this building. Whereas, and then I think Octopus came out trying to redesign the heat pump, and that looked awful as well. As much as I don't like Tesla and Musk, they kind of need to come in and design a heat pump that actually looks nice and looks stylish. I know people, point out how nice your home boiler, but a heat pump is outside, so it's visible. So the aesthetics, I think, are more important than the aesthetics of a boiler. But you're right, yeah, that's probably why you can show off your new kitchen. You've got to be very niche to show off your heat pump. Yeah.
And there are some research to ask about consumer preferences for retrofitting. And one factor here is whether the retrofitting improves their property or improves their neighborhood. Because if the improve the green area of their neighborhood or it improves the water drainage, they are more preferred by the neighbors, by the people here.
I think that there is the area based. Is Mrs. Smith down the road doing it, and with retrofit, often when it's external insulation, the problem you face is mixed tenure. So you could have 3 or 4 homes with where the external insulation is done, and then one that is not because it's not part of the scheme, and then it looks horrible. So it's challenging, all retrofit is.
It wasn't so much a question as I've heard that he said, as someone who's keen to buy, monthly cost definitely resonates as the main issue. However, when I've looked into this, there hasn't been a monthly reduction. This is potentially due to it being an older house, actually, because Angie also commented that the VAT on electricity, but not on gas, these results would support that policy change if monthly cost is a main driver.
Yeah. First, the savings of retrofitting all this new technology are calculated based on their previous consumption. So, for example, if they consume more electricity, the savings will not be that significant. And then another concern is the support from the policy and the tariffs for this new technology or demand side response, because sometimes the tariffs may not support this new technology, or if you take part in demand side response, it needs to be coincide with the electricity price so that you can get the reward of incentives. Yeah.
That's it for the online questions.
No, which it's the other policy recommendation could be it's reducing the spark gap between gas and electricity, removing the levies, but not from electricity. And I think that'd have to go into general taxation, because you can't just switch them over to gas. Even though you want to discourage gas use, you've got an equity question. Is that the people who won't be able to afford the retrofit to reduce their, they've got to carry, if they're paying more for their gas, in deprived areas or vulnerable people. So you've got to take it, put it into general taxation, and then reduce the spark gap to encourage. You've almost got to use the carrot to encourage electricity rather than the stick to discourage gas.
And there are always research about the equity here. What's the impact on low income households and high income household? Yeah, that's definitely interesting research. Yeah.
Interesting. Thank you.
Thank you.
Very much.
And thank you for coming here.
No, thank you.